So in the last video, we looked at how to change from a cell diagram to cell notation. So in this video, we'll go backwards just for fun. So perhaps you had this for your cell notation, and you were asked to convert this into a cell diagram. That is a picture of how you would build the cell. We'll go through this together, and if you like, you can pause the video and have a go and compare notes, and otherwise just wait a few seconds and I'll go through it together. Okay, so we need to understand how to read this, and the electrodes are always written at the far side. So there's an electrode there, and there's another electrode all the way over there. And the electrodes are the bits of metal that stick into the solution. So ultimately, we've got to connect a wire to the electrodes to measure the voltage or to transmit the electrons from one side to the other. So we're always going to need something like a wire, a piece of solid copper or silver in this case. The vertical lines, of course, are the cell boundaries. So we've got a solid and we've got an aqueous phase here. This double line, do you remember what this was? Yeah, that was the salt bridge. Okay, so now we can have a go at constructing this cell diagram. So we know that the left-hand side is the anode by convention, and the right-hand side is the cathode. And by convention, when we draw these pictures, we draw the anode on the left and the cathode on the right. Okay, so the anode must contain a piece of copper. So we're going to have a copper strip. All right, so you can just go to your friendly copper store and buy a piece of copper. And it's going to be dipped into a solution containing copper ions at a concentration of 1 mole per liter. So, okay, so how would we write that? I guess we could just write Cu2 plus, aqueous 1 mole per liter. And where might that come from? Well, maybe we've got 1 molar copper 2 nitrate perhaps. So the nitrate ion is a nice, stable, inert, unreactive ion. So that would be a very good way to produce 1 molar copper ions. We've got the salt bridge. So we're going to go ahead and we're going to draw one end of our salt bridge and the other end. And it is just a tube filled with an ionic compound that's just going to keep the charges balanced. The typical fluid we use is maybe some potassium nitrate. So potassium nitrate contains potassium ions and nitrate ions, and we normally incorporate it in a gel and put a little sort of plug at the end just to stop the solutions from mixing too freely. So there's my other beaker, and I could draw my meniscus level like so. All right, so why do we have that potassium nitrate in the salt bridge again? Well, remember at the anode, that's the site of oxidation. So oxidation is loss, so that means that the copper is forming copper 2 plus and 2 electrons. And of course, what that's going to do is that's going to increase the copper 2 plus concentration in the solution. So that means these nitrate ions are going to migrate into the left-hand beaker to keep them neutral. All right, so we're going to need some wire here. So we're going to go ahead and we're going to hook up that electrode maybe to a voltmeter so that we can tell the reaction's going. It's going to measure the amount of energy the electrons are moving from side to side with. And then we're going to need to connect it to another electrode. So we're using silver on the other side. So we would have a nice silver electrode. I guess silver is going to be yellow, and I'm going to draw it right through that nitrate ion because I wasn't smart about this. AGS, so go to your silver store and buy some, and then we need to immerse it in a solution containing silver ions at a concentration of 1 mole per liter. So I'm just going to write Ag positive, aqueous, 1 mole per liter. And how might we prepare this solution? Well, maybe we have 1 molar silver nitrate. That would be a good way to do it. We can also write down the cell reaction just for completeness and remember a red cat and an ox. So reduction occurs at the cathode, oxidation at the anode. So reduction is gain of electrons. So oil rig, oxidation is loss, reduction is gain. It's a lot of mnemonics to remember here. So we're going to go ahead, we're going to pick up an electron. So the silver ion is going to go ahead and react with a single electron. And it's going to form silver that's going to just start depositing out on that electrode. That's why we have the electrode there. And we should measure a voltage. In fact, we can calculate the voltage of this cell. In fact, the voltage of the cell we are going to write as E standard. And sometimes we write a little cell to remind us. And this is the voltage produced by the cell under standard conditions. And standard conditions meaning that we're under 1 mole per liter solute and we've got pure solids. So in the next video, we'll learn how to calculate that. Sounds like fun.